morning, children. Welcome back to our online class. I hope that you all are safe at home. Yes. Are you all happy, children? Do you have interest to learn Science 1? Yes. Children, now we are learning the lesson 13, that is electric current and its effects. Is it? Yes. In the last class, we have learned about circuit diagram. So, shall we recall now what we learned? Okay, so what is called an electric circuit? The unbroken path through which an electric current can flow is called an electric circuit. Then what is called circuit diagram? A drawing of an electric circuit with the standard symbols is called a circuit diagram. Yes, after we have seen some basic components of electric circuit and its standard symbols. I hope that you have learned that how to draw the symbols of that basic components. Okay, next we have seen the important points to remember while drawing circuit diagram. What are the 3 points I said? There should be a source, that is one or more electric cells. The wire should not have any discontinuity, that is gap. Then the only component that can have a discontinuity is in the switch. When it is open, there is a discontinuity, current does not flow in the circuit. Is it? So these are the points, 3 points we should remember when we will drawing circuit diagram. Is it? Next, today we are going to learn about how to connect cells to make a battery. By connecting cells together, we can increase the voltage output. Example, if we have 3 1.5 volt cells, we can connect them together and form a battery which gives 4.5 volt. How? 1.5 plus 1.5 plus 1.5. The cells, so we will get 4.5 volt. The cell should be connected in such a way that the positive terminal of one cell is connected to the negative terminal of the next cell. Care should be taken to connect identical cells. Okay. So this is about how to connect the cells to make a battery. Okay. Next we are going to learn about cell holder. Cell holder. Have you seen cell holder? See the video that I have shown the picture. Cell holder. Most battery operated devices have a place where the cells are to be placed. This is called a cell holder. Cell holders are also available separately and can be used in electrical circuits as needed. A cell holder is an open box generally made of plastic with metal contacts. They are designed to hold one or more cells. They have positive and negative signs inscribed inside where the positive and negative terminals of the cells fit in. Okay, this is about cell holder. Children, next we are going to learn about heating effect of electric current. Listen children, try touching a torch bulb that is lit and another that is not. Be careful when you touch the lit bulb. Do you feel it is hard to touch? Yes. In an incandescent bulb, electric current passes through a very thin wire made of special material such as tungsten called filament. When the bulb is switched on, the filament gets heated. This is due to the heating effect of electric current. Is it? Yes. So what is called the filament? In an incandescent bulb, electric current passes through a very thin wire made of special material such as tungsten called filament. When the bulb is switched on, the filament gets heated. This is due to the heating effect of electric current. Have you all understand? They'll ask. So, if they ask what is called the filament, you want to write a 2-mark question, important. Then you want to learn that one very clearly. Okay? Yes. Children, a disadvantage is an advantage. Generally, heating effect of electric current is a bother. because it results in a loss of electrical energy and also results in the damage of electrical appliances. However, the same heating effect can be put to good use. Many electrical appliances that we use every day actually make use of the heating effect of electric current. This is a classic example of how a advantage can be turned into an advantage. This happens very often in science. When you find a disadvantage in a particular effect or situation, look to see how can turn it into an advantage. The heating effect of electric current is used in several appliances which include electric toasters, electric irons, hot plates, electric hair dryers, and electric ovens. These appliances contain tightly wound coils called elements. The element heats up when an electric current passes through it. In many electrical appliances where the element is not covered, it can be identified by its dull red glow when the appliance is on. Okay, so this is about the heating effect of electric current. Now we are going to learn about this heating effect of electric current through an activity. Okay, that is, the aim is to show the heating effect of electric current. Okay, so you can also try. For this activity, what and all you need 1.5 volt cell, for example, okay, or 3 volt cell, 2 pieces of wire, a small torch bulb, insulation tape. Okay, so method: strip the insulation at both ends of the two wires so that about 1 centimeter of the metal portion is exposed. Connect the negative end of the cell to the threaded portion of the bulb with one of the wires. Secure both ends with the insulation tape. Connect the positive end of the cell to the bottom portion of the bulb with the second piece of wire. Secure both ends with the insulation tape. Okay, now what you can find there? If you connect that properly, the bulb, it will started to glow. Is it? Yes. Now if it does not glow, adjust the connection till the bulb glows. Okay. Then touch the bulb to see how hot it is just when the connections are complete. And leave this arrangement for some time and then touch the bulb again. Okay. So what you will observe at that time? Bulb is a little warmer now than at the beginning. So conclusion, this is because the passage of electric current heats it up. So while you are doing this activity, follow the precautions given, that is what I am going to say. Okay. Touch only the insulated parts of the wire connected to the terminals of the cell. Do not perform the activity near inflammable materials such as kerosene, petrol or a gas cylinder. Do not use a cell of a higher voltage than specified, that is 1.5 or 3 volt. Okay. Do not use the plug points of your house or school. Understand? So this is the activity that is showing heating effect of electric current. Can you try? Okay. So make the parent to stand nearby you while you are doing this activity. Understand? Next topic, we are going to learn about electric fuse. Electric fuse. So children, what will happen if a large amount of electric current passes through an appliance? Think it. It causes the wires to get overheated and the appliance gets damaged. This situation arises as a result of some fault in the circuit and can be extremely dangerous as it can lead to fire. To prevent electric appliances from getting damaged from an excessive flow of current, a safety device is called a fuse is used in the electric circuit. Okay, electric fuse prevents a large amount of current from flowing into any appliance or device as it cuts off the supply of electric current, thus preventing further damage. Do you know which principle it is working? What is the principle it is used to work? That is heating effect of electric current. Okay, heating effect of current. The electric fuse works on the principle of heating effect of current. This is one word, very important. Okay, heating effect. The amount of heating caused depends on the amount of current flowing through the wire. The greater the current, the more is the heat produced. So current amount of current, if it is more, the heat produced is also more. Okay, an electric fuse consists of a thin wire usually placed inside a glass or ceramic cartridge. The wire is made of a material that melts easily when heated. Examples of material used for fuse wire is lead, tin, alloys of lead and tin, aluminium, zinc, etc. It is designed such that only a certain amount of current can flow through it. If the current exceeds this amount, the heating in the wire causes it to melt. We say that the fuse blows. This breaks the circuit and stops the flow of current in the circuit. Miniature circuit breaker. So nowadays we are using this in our houses. A miniature circuit breaker is an automatically operated electric switch that protects an electric circuit during an overload or short circuit. They can be reset to restore normal operation, whereas in the circuits with fuses, the fuse needs to be replaced after a single use. You can find this on the distribution board or switchboard of your house. So today you see in your house, that is the miniature circuit breaker. The picture I have shown in this video, that is the miniature circuit breaker. Okay, so this fuse is a safety device, is it? Safety device. So when there is excess of current, it will save your appliances which you used, electrical appliances which you used inside the house. Okay, which principle the fuse is working? Heating effect of current. Okay, so this lesson you want to read, that is from the page number 200, 201 and 202. Answers I will give through WhatsApp. Okay, and if you are attending the class Zoom, there also I used to give. Okay, so, thank you children, thank you.